You know, we live on this perfect blue marble, a planet that seems just made for us, floating in this vast, empty space. But have you ever stopped to wonder how it even got here? Well, today we're diving into the epic 4.5 billion-year-old story of Earth's incredibly violent, chaotic, and frankly, miraculous birth.
But to tell that story right, we actually have to start with a mystery. I mean, just look at our planet. It's covered in water. But where did all that water come from? For the longest time, this was one of the biggest questions in science. And funny enough, the clue that started to unravel it all came from a NASA mission aimed at a distant icy comet.
That mission was called Deep Impact, and back in 2005, it took off on a journey of over 270 million kilometers to find an answer. But to really, truly understand what it discovered, we need to rewind the clock way, way back, before the Earth, before the Sun, to the very, very beginning of our solar system.
Okay, let's go back 4.5 billion years. The spot where our solar system is right now, well, it was once just the edge of the Milky Way galaxy. There was no Earth, no sun, nothing but a colossal dark cloud.
And this wasn't some rain cloud. Scientists call it a molecular cloud, and it was packed with dust and gas. Basically the leftovers of ancient stars that had lived their lives, burned out their fuel, and then exploded, scattering all their elements across the universe. This was the raw material for everything that was about to happen. And this cloud was huge. We're talking about 100 light years across. To put that in perspective, a beam of light, the fastest thing in the entire universe, would need a whole century just to get from one side to the other. It was over 6 million times wider than the distance between the Earth and the Sun. So, how on Earth does a cloud like that become a planet?
Well, the first clue actually came from a really simple experiment in a very, very complex place. Back in 2003, an astronaut named Don Pettit was up on the International Space Station. Just for fun, he put some salt into a plastic bag and shook it up. And in zero gravity, something pretty amazing happened. The tiny little salt grains started sticking to each other, just forming little clumps all on their own.
And believe it or not, that is exactly what happened in that giant molecular cloud. All these tiny dust particles, just floating around in space, began to attract each other. As they gently bumped and collided, they stuck together, creating bigger and bigger clumps, all thanks to that one universal force: gravity. So as gravity pulled more and more material inward, the whole cloud started to spin, flattening out into this vast disk. Right there in the center, all the pressure and friction from those colliding particles generated an incredible amount of heat. For millions of years, this core just got denser and hotter until, finally, it ignited into a massive fireball. Our sun was born. So what about all the other stuff? The leftover materials swirling around this new star. It didn't just vanish. Nope. It kept on clumping together, forming not 8 planets, but around 20 baby planets, or protoplanets. And they were all jostling for space in this chaotic, supercrowded orbit around the brand new sun. The early solar system was basically a cosmic demolition derby. It was total chaos. These 20 planets, all being pulled by each other's gravity, started smashing into one another. And with each colossal impact, 2 planets would merge to become one bigger planet. After millions of years of this violence, the solar system finally cleared out, leaving just a few survivors, including our own planet. But this early Earth was nothing like home. It was a searing ball of molten rock. I mean, it was an absolutely hellish environment. If any kind of life had somehow managed to form back then, it would have been vaporized in less than a second. And just as the planet started to cool down a bit, it faced its first huge threat: ferocious solar storms coming from the young, really unstable sun. So how did Earth survive when a planet like Mars had its whole atmosphere stripped away by these same storms? Well, the secret is deep inside. As Earth was forming, heavy metals like iron and nickel sank right down to its center, creating a molten core. And as the planet rotates, the spinning liquid iron acts like a giant generator, creating a powerful magnetic field that stretches way out into space. It's a planetary shield, and it deflects those deadly solar winds. Okay, so Earth had a shield. It was starting to take shape. But its most dramatic and maybe its most important chapter was still to come. It was about to suffer the single biggest impact in its entire history. A rogue planet about the size of Mars, which scientists have named Theia, came hurtling through the solar system and just slammed right into our world.
The impact was cataclysmic. A massive spray of molten rock from both planets was blasted into space, and over thousands of years, gravity pulled all that debris together to form our moon. But that wasn't all it did. The sheer force of that collision literally knocked Earth sideways, tilting our planet on its axis to the very precise angle of 23.5 degrees. And that tilt? That is the reason we have seasons. As Earth orbits the sun, the tilt means different parts of the planet get more direct sunlight at different times of the year, giving us summer, winter, spring, and fall. Without that one impact, our climate would be completely different.
So, the stage is set. We've got a rocky planet, it's protected by a magnetic field, it's tilted perfectly for seasons, and it has a big moon to stabilize its orbit. But it's still just a dry, barren rock. Which brings us all the way back to our original question. Where did the water come from? Let's get back to that NASA mission, Deep Impact. So on July 4th, 2005, after its long journey, the probe released a 350-kilogram copper impactor. Think of it like a giant copper bullet. This thing smashed into a comet called Tempel 1 at over 38,000 kilometers an hour. From a safe distance, the main probe just watched, using its telescopes to analyze the light from the explosion. And by analyzing that light signature from the cloud of debris, scientists confirmed what they suspected for a long time. The comet was packed with water ice. This was the smoking gun. Comets, these dirty snowballs from the outer solar system, they were the delivery trucks that brought water to the early Earth. Okay, so we found the source. Awesome. But, this just raises another question. These comets are supposed to be orbiting the sun way, way out in the asteroid belt. So how did billions of them break from their orbits and make that incredibly long journey to crash into Earth? The culprit? Well, it was Jupiter. As the biggest planet in our solar system, its immense gravity can mess with the orbits of pretty much anything nearby. Astronomers think Jupiter's gravity pulled on comets in the asteroid belt, basically flinging them out of their stable, circular orbits and sending them hurtling on these new, oval-shaped paths toward the inner solar system and right into Earth's path. And we even have geological proof for this timeline. It's really cool. Geologists have found these tiny zircon crystals, which is a mineral that can only form when water is present. Using radioactive dating, they figured out that the oldest of these crystals are 4 billion years old. Now, since Earth is 4.5 billion years old, this proves that the water got here about 500 million years after the planet had already formed. It was a late delivery. I mean, what an incredible chain of events, right? A giant cloud of stardust, a violent planetary pileup, a planetary shield, a collision that forms a moon, a perfect tilt, and then a special delivery of water, courtesy of Jupiter. Earth was almost ready. So let's run through the checklist, shall we? We've got a magnetic shield to protect us? Check. We have a stable tilt giving us seasons? Check. And now we have vast oceans of water? Check. All the pieces really seem to be in place for life to get started. But there was one final, absolutely critical ingredient missing from the air itself. So our planet wasn't a molten fireball anymore. It was a water world, shielded and stable, but its atmosphere was totally toxic, with no breathable air. It had everything it needed for the story of life to begin, except for oxygen. So the big question is, where did that come from? And that's a story for another time.